So welcome to lecture 2 of algorithms. Today we'll be talking about pseudocode and recursion basics. Effectively, we'll start learning almost a new programming language called pseudocode. Most of you should have already seen some form of this before. We're going to have a specific version of pseudocode in our class just so that things are easier for everyone involved. We're going to take a lot of time practicing working with the pseudocode and understanding how and why we use it. And then if we have time left, we're going to go and tackle recursion. Now, I'm not going to go into recursion very deeply during this lecture. I'm actually going to post an optional lecture. No, not optional. I'm going to post a lecture that I expect you all to watch for next week's homework, and it will be on the quiz. This is in lieu of being able to give you a more thorough in-class review of recursion, because this is technically something you should have learned in a previous class. But I know a lot of people are still a little bit shaky on it, so we have a video lecture for you to watch in order to catch up. Let's just get started. So blue background here means that you should take notes. This is definitely going to show up on a quiz later. What is pseudocode? In this case, it is a way of writing out the steps of algorithms where we want to describe what we want the computer to do, but not write quote unquote real code. So it's essentially a way of letting you talk about coding without having to type something out on a computer or otherwise think very carefully about syntax, right? There's a lot of different kinds of pseudocode. We're going to use our own custom one. Your book has one version. My book that I learned from when I took algorithms has another version. And we're going to use the version that I referenced and kind of came up with specifically for this class that I think is going to be the most effective. The hope, though, is that again, pseudocode allows you to focus on the logic of a program. So it allows you to think more closely toward just the ideas of how to solve a problem, instead of just thinking about like line by line exactly what you need to type into a computer, which in theory should help you solve problems more effectively. We use it to catch logic bugs. What that means is like maybe off by one errors, or you missed an edge case here or there, or you missed the base case if we're talking about recursion. And it should also include enough information. All pseudocode should include enough information to write actual code, right? So it should be one-to-one to what essentially like a set of instructions you read in order to actually type something out in Java, Python, C++. And you'll have sufficient information to be able to effectively use it to write something out, right? So again, this is a blue slide, so we expect you to just take down notes for this slide. I know the slides will be posted afterwards, but studies have shown, research has shown that if you write notes during an actual live lecture, you learn a lot more. Right? But this is definitely going to be something to remember and understand. Why do we care about pseudocode? I'm going to give you all about 10 seconds to type in your answer into chat. And then when I say so, everyone's going to hit enter. For those of you who are new to the lectures, this is a style of lecture where we do participation, like we do want everyone to participate in class. So we right now are going to type in, what do you think, like, why do you think we care about pseudocode? And then when I say so, everyone's going to input their answers, right? Participation credit is worth points in the class. Like you get a grade for it. It's 5% of your grade. And generally speaking, it helps me know where the class is at, whether or not I need to review something I just said, as well as whether or not I can go faster. All right, go ahead and hit enter now if you have an answer. Goal here is for everyone to answer here. Everyone should be able to give me an answer. It doesn't have to be like the best answer in the world. I'm not looking for right or wrong. I just want to see what you're thinking right now. So a lot of people are saying it's easier to understand in code. It simplifies the end goal because it removes a lot of the syntax issues. It's like nice to get to the essence of what we're talking about, right? Talking about the ideas instead of the details. We care about pseudocode because it actually puts what we think into words without actually coding, which is great. Language agnostic, which is really good. In other words, you don't need to know Java or Python or C++ in order to talk about pseudocode. Everyone who knows different languages will be able to speak one set of, will be able to use pseudocode to speak to each other. Because it's nice. All right, that's fair. I think it helps us visualize code. It summarizes thoughts into logic. It gives us a rough idea of the solution to the problem to understand it easily. Because it allows us to write out the logic, it's easier to understand because it's in like normal plain words instead of code. All right, nice. If you still are typing out your answer, feel free to. I'm going to keep going and talk about what I think. In this case, the main thing here that I think is beneficial is that it forces you to reason about logic without using a computer. Right. I mentioned in the last lecture that this class helps you with problem solving, and problem solving is a skill or a muscle, just like running or swimming or any other physical activity. So in this case, pseudocode gives you a way to practice your problem solving abilities, and it takes away the computer, which can help and can hurt in some instances. Right. Most computer scientists, most software engineers know how to talk about code without necessarily being in front of a keyboard. And that's a skill I would think most people expect software engineers to have. So we're going to do it here as well. It's easier for humans to read. Pseudocode is easier for humans to read, and it's used a lot of times for planning. So when I work at Facebook as a software engineer, I actually do talk to my coworkers in pseudocode. I don't just like show them a bunch of code I've written and be like, here it is. Usually beforehand, I plan out what I want to do. I make sure that my plan makes sense. I show them maybe some pseudocode or some logic on how to do it. And then when I actually write the code, they're already with me. They actually know, oh, I'm just seeing Andrew's plan and seeing how he wrote it in code and making sure that it matches up, right? So a lot of times you'll use some form of pseudocode or some form of pre-planning with pseudocode to understand what's going on. You don't have to worry about syntax. You don't have to worry about compiling, right? Because you're mostly using words in order to explain something. Oftentimes it'll be shorter and easier to fit on a slide, which is really important for me as a professor, right? And it's a skill, as I mentioned before, that a lot of people use. Pretty much all software engineers are familiar with pseudocode. It might come up in interviews, it might come up in design meetings, so on and so forth. We're going to use pseudocode for the rest of the course, right? It's not going to go away. We're going to learn it right now. We're going to build upon it over time. And the expectation is that you get really good at it. The goal is to feel as comfortable with pseudocode as any other language. Right. And again, if you're new or if you don't remember, you can ask questions at any time just by typing into chat. And then at the end of a slide, I'll typically answer questions as they come up. Right. So don't hesitate to ask questions. If you feel like the question's a little bit silly, don't worry. I answer all questions that I see. If there's a question that takes longer to respond, I'll answer during a break or after lecture. Okay, so let's go ahead and jump into examples. This is like the fastest way to understand pseudocode. So we're looking at some Java code on the left here, all right? Type in min of list if you can hear me and you can see this screen. Min of list. All right, great. I'm glad everyone is listening because it says max of list on the screen. No one has fallen for this trap yet, which is excellent. I really love that people are following along. All right, so max of list here is a function that takes in a list of numbers, right? A list of integers in this case. And then it tries to find the biggest number by iterating through every single element in the list and comparing it against negative infinity at first, and then the next smallest thing it finds in the list. And then it just keeps track of what is the smallest thing at any one point in time and updating it as you iterate through the list. It'll return that value at the end. Sorry, let me try that again. It tries to figure out what the largest thing you've seen in the list is so far. I fell into my own trap. But the largest thing so far starts as negative infinity. That's what it means when it says integer.min value. And then it iterates through every single element in the list and tries to update back so far with the largest number it's seen so far. And then we return it at the end. All right. Here's the pseudocode equivalent on the right. I'm going to give you all 20 seconds. And what I want you to do is think about what are the things that are the same and what are the things that are different. Like, what do you notice? And I'm not looking for anything in particular. I just want you to start looking at the left and right and comparing. And then we'll try to break it down together and kind of identify all of the parts that are like analogous to each other and understand what are some kind of the differences as well. All right, 20 seconds starting now. Again, you should be typing into chat, but not hitting enter of any differences you see between the left and the right here. All right, go ahead and enter what you've seen. There's a question, isn't min value an actual value not representing infinity? That is true. Technically, it is an actual number because there are limitations to how Java represents numbers. So min value is an actual proper number. I'm saying it's negative infinity because that's technically what we usually mean and what we represent it as, like what it's used to represent whenever we see it in Java, right? It's a number that we don't expect to actually show up in normal use. So for the most part, we can use it as negative infinity. For loop is typed out. Code has more specific syntax. No language specific words. That's a good one. Pseudocode is nicer to look at. Less punctuation in the pseudocode. I didn't initialize max so far on the left. Wait, I totally did. It's right here. It's the second line. Functions are the same, not really different, much more readable. Same methods and returns, no brackets. Negative infinity isn't a number. Looks roughly the same. Actual number and int max so far. Don't have to end statements with the semicolon. That's a good one. All right, cool. So let's go ahead and do some more comparing. So you notice that there's a lot less syntax for the right-hand side compared to the left-hand side, right? The first thing we look at is this first line in the actual Java code. For those of you who remember Java, this is public static int, which means that this is a function that we're creating that we don't have to initialize an object in order to use. And it's going to return an integer here, right? So this is like the equivalent of what we see here. And we know that it's going to take in a list of integers as input, right? So this entire 3 lines on the top here is almost the analogous of what we see on the left here, the first line here. Now, the thing I want you to notice in particular, though, is that the output being described is a lot more specific than just this thing here, right? When I say int here, all we know is that some number will come out. We don't know if it's going to be a big number, a small number, a positive number, a negative number, whatever. But here we get to say exactly what kind of number it's going to mean. We introduce context and meaning into the output, right? So one thing to know is that the output should always be very contextual. Input and output always tells us exactly what the problem is, right? If you remember from last lecture or from the quiz, the whole point of input and output is to describe the problem, right? The problem gives us or enough context to tell us what the algorithm actually does. And if you think about it, we need to be very specific. If there are any edge cases, we want to specify it in here. And so instead of just saying any old number comes out, we're saying the largest number from the original list comes out. All right, and that's really important to note. So write this down in your notes, and we'll move on. Okay, if we move on and we look at kind of how max so far is assigned, let me keep this red, and then I'll go back here. All right, so max so far is used a couple of different places, right? We'll use it here, and there's the equivalent line here. We'll update it here, right? And here's the equivalent line, and then we'll return it at the end. Some of you say, oh, this looks pretty much the same. Some of you notice that there are a lot less syntax and punctuation that's being used. No semicolons. You don't have to say like int max so far, because if you see negative infinity, you know that max so far is going to be some sort of number, right? So we just assume that. And then like we don't have to worry about these brackets or anything like that. And then lastly, we have this for loop, which is I think the most interesting part. The for loop here, instead of saying for int I is equal to 0, I is less than list.size, I plus plus on this left-hand side, which is a very common way in Java to iterate through a list or an array or anything sequential, right? We just say this. What does this mean in words? It means that we're going through every single element in the list. And that element is going to be represented by EL here, right? So EL is being used, and EL is basically the same as list.get of I. Right? On the left-hand side, we use an actual explicit index. And on the right-hand side, we just say, okay, this element actually is what we care about. So we're going to go ahead and skip the indexing. Now, if you use Python, this should look a lot like Python. I coded in Python a lot in the past, so our pseudocode is going to look very Python-y. But by design, Python is also meant to be like very easy to read, which is why our pseudocode will look very similar, right? Because they both are supposed to be easy to read. Does anyone have any questions about this before I move on? Now's the time to ask. All right, we're going to look at a few examples, and then we're going to start using it. All right. While you're typing up questions or waiting for me to move on, I do want to point out that on the course website, there is actually a guide on how to write pseudocode. I will show you that in a second, actually. Let's just move on and continue using pseudocode and reading it right now. What exactly does the code do again? We will take in a list of numbers, and we're going to just return the biggest number out of the list. All right. So if the list is empty, it will just return negative infinity. So I should actually point this out. One thing that you could add more detail into is to say, if the list is empty, return negative infinity, right? And I would also include that in the output. Or if you want, you could also just specify a list of size 1 or greater, one way or another. All right, great question. I'm going to move on. So let's go ahead and see how we can change pseudocode and how we can change Java. I'll give you all about 30 seconds. Think to yourself, what changes would we have to make to actually make this into min of lists, right? Right now, this takes the list of integers and returns the biggest integer. And I'm just asking for some changes on both the left and right-hand sides to make this a function that will return the smallest value in the list instead, right? There's a couple of changes you'll have to make, actually a lot of changes on each line. So you do want to keep track of those changes. You might want to type it into a text editor instead. I'm giving you maybe another 20 seconds, type it into a text editor and then copy and paste it into chat. And when I say so, hit enter. Right, both the pseudocode changes and the Java changes. Oh, I mean that someone's asking copy from where? You can just type it into like a text editor, like open up Notepad or text edit or something like that. That way, if you have a lot to type, you don't have to like worry about accidentally hitting enter. No worries. Yeah, a lot of people in chat have been like accidentally hitting enter early and like spilling a little bit of your answer, and that happens. And I think the easiest way to fix that is just to have a text editor open while we're taking lecture. All right, you got about 5 seconds left, so finish up and then go ahead and hit enter now. What do we have? Right, everyone should be answering, even if you don't have a complete answer, even if you're not 100% sure, give it your best shot. We do grade you on whether or not you participate, not the quality of your participation. Okay, not the correctness of your participation, but the quality of your participation and the volume go into how I assign 5 points of your final grade, right? So if you're answering and you're not quite sure what's going on, that's totally okay. I just want you to think in class, right? I want you to exercise that muscle and make sure that you're feeling good about thinking through things. And if you're completely confused, you can just say, I don't know, I'm confused. And that's perfect because that tells me that I should go back and explain some things better in a different way. All right, so we got a bunch of answers. Let's go ahead and start making some of these changes. So instead of saying max everywhere here, oops, my cursor is very small. Instead of max here, we're gonna go ahead and change this all, right, to min. That's gonna matter a lot. So I'm just crossing it out now, and I'll type in the corrections in a bit. But for now, we know that these parts will all be changed, right? And if you're still typing in your answer, that's great. Keep doing it. And then, we need to add the correct answer. So let's go ahead and type in some changes here. So instead of saying max everywhere, we're going to say min. Oops, this is not the right color. There we go. Min of list. Min goes here. Instead of saying min here, we actually have to say max, because if you're trying to find the smallest number and you need some default value to override when you're looking through the entire list, you want to start with the biggest number so that any number that's smaller than positive infinity will replace positive infinity for min so far. Right? We have min so far here. We have min here. And we have min here. You see that this isn't supposed to be super scary, right? And so if you are like following along being like, hey, this makes sense, well, first, don't let your guard down. But second, that's on purpose, right? This isn't meant to be intimidating. We're just trying to see how pseudocode works and how code would work when staring at this stuff, right? One thing that might be interesting for you to think about is what level of Bloom's taxonomy am I asking you to do right now? Feel free to type in chat. This is like a rhetorical question, but if you feel like you have a good answer, go ahead and ask. Is there anything here that I'm missing that I need to change now? Do we need to change the infinity? Yes, we do. Someone caught it. Thank you. So this should be positive infinity instead of negative infinity. People are saying this is apply. Some people are saying this is analyze. Yeah, I think that's right. I think this is a combination of apply and analyze right now, because you have to think about, for example, how do you change the logic, which is more of an analysis problem. And then you also have to think about, like, how do I just use pseudocode, which is more apply, right? It isn't too complicated, so it's not like evaluate or synthesis or create in this case. But any other things that I have to change here? Am I missing anything else? Last section, I actually missed a few things, and people in chat were able to catch them for us. I think we got everything, but give me a yes in chat if you feel good about this code, all the changes we made in order to make it min of list. All right. Cool. So we'll move on, and we'll actually see all of the changes that we had to do. So here's all the changes minus one change that I need to update on the slides. I said I would update it last time and I forgot, but this should also be min so far, obviously. Cool. Right, and these are all the changes we mentioned before. All right, so let's go ahead and take a very quick break. No, actually I lied. We're not gonna take a break. We're gonna go do this first and then we'll take a break, I promise. All right, so in this case, we have a little bit more code here. And when I say a little bit, I mean a lot more. It's in pseudocode. And the question here is, what are all the bugs in this code, right? The idea behind pseudocode is that when we write pseudocode, it should allow us to think about the logic bugs. I've purposely written bad code here. There's some things that are wrong here. I'll give you all about 1 minute to try to spot all the bugs. And one thing that might help you is try to run a small example, like a small list that gets passed in, and see if you can figure out what are all the changes that need to be made in order to fix this. And then we'll go through it together in about a minute or two. All right, so I'll give you all about a minute here. Go ahead and use your text editor to type in all the changes or all the errors you're seeing. Being able to find a bug in pseudocode is closer to analyze, maybe evaluate, and it's definitely something that we expect you to do on a homework or on a test later on. Okay, you got about 15 more seconds. Again, you should be typing up all of the errors you're seeing in this pseudocode. What is wrong with this logic? This is relying on your previous programming knowledge. You can see here that we're taking in a list of integers where the size of the list should be 1 or greater. And then we're trying to output the second smallest element in the list, right? So before, when we were looking at the code, we had min of list. Now we're seeing basically the second smallest or the second min of list, right? The second smallest element in the list. That's what we want to output. All right, go ahead and type in chat what errors you see. Okay, we're getting some comments to flip the infinities. We're saying that we should return second smallest instead of returning EL. It says that it skips the lists that are exactly size 1, which is probably a mistake. Well, we know that the size of the list has to be greater than 1. That's an assumption we make about this code. If you look at the second line here in input, so we just assume here that this is good. Right, I'm reading chat right now. People are giving some very good answers. Most people are catching most of the bugs. But if you are catching bugs still, go ahead and type in what bugs you've talked about. All right, so let's see if we can catch them here. We're gonna go ahead and start by doing the most obvious things. Instead of negative infinity, this should be positive infinity, because if you start with a number, right? If you start with any example, let's use a very small basic example here. If we have 1, 2, 3 here, right? What should we output? Type in what the output of this function should be on the list 1, 2, 3. Should output 2, right? So everyone's cool. This should be outputting 2. So let's see what the code does if we have it written as it is right now. So we're going to go through and we're going to iterate through every single element in the list. First off, is this list greater than 2 elements? It is, so we're cool. Then we're going to go ahead and see if the current element, right? So we say first smallest is equal to infinity, and then second smallest is equal to infinity, right? We're just going to keep track of the variables that we need to update over time. And then we're going to say EL starts with 1, right? Because EL is going to be every single element in the list, and the first element it examines is 1. And we're going to check, is EL less than first smallest? In other words, is EL less than infinity? Yes or no, chat? I should get 51, 52 answers here, right? Even if you're guessing, you should be able to answer this one. If you don't answer here, that's like participation points being lost here. All right, so hopefully I'm seeing like 50 answers. I'm not going to count all of them. I'll run a script later. I do keep track of participation every week. All right, so we are getting, in this case, yes, which means that we set first smallest to 1, and then we're going to set second smallest to first smallest. And some of you mentioned that this is going to be a problem, but we're going to keep going and see what happens. All right. Now we check again to see if 1 is less than second smallest. And in this case, right now, 1 is not less than 1. So we skip this assignment here. Right? And then we go and say EL is now equal to 2, right? We've moved on and we're examining the second element in this list. And we say, is 2 less than first smallest? Yes or no, chat? All right, we're getting a bunch of no's in chat, and that's correct, right? Because 2 is not smaller than 1, quick maths. And then since we don't, since the first thing here, the first if statement, its conditional clause is false, we actually go to the second if statement, else if EL is less than second smallest. Now, second smallest right now is 1, because that's what we assigned before, just following this code blindly. And EL right now is 2. What's wrong here? Go ahead and type in chat if you know. What's the problem here? I'll give you 10 seconds. Formulate an answer like, is this right? And if not, then what's the issue here? Why, if we look at this else statement where an EL is equal to 2, are we in trouble? Go ahead and type in chat if you know. Okay, someone said that you can't initiate both variables to the same value for this algo. Because second smallest will always be equal to whatever first smallest is. Right, so once second smallest is equal to 1, it's game over, right? Because we need second smallest to equal to 2, but based on this logic, it's never going to be equal to 2 because we never get to this else if statement, the body of the else if, because 2 is not less than 1, right? So this should have stayed infinity, all right? And if you're having trouble seeing it, go ahead and ask me questions. We can also talk about it during break. But the idea here is that EL right now should be set, like second smallest should be set to what the current EL is. But this is not going to happen because we already set second smallest to 1. And since 1 is smaller than 2, we're kind of in trouble. So the fix here is actually, we're going to switch the conditions. We're going to switch the conditions so it looks like this. We're going to say that the first thing we do is set second smallest to first smallest. And then the second thing we do is to set first smallest to EL. All right. Let me just show you what that happens in the code when that happens. Let's just go back into the world where we are at the beginning of the function. Right. And if you have trouble understanding what's going on, feel free to ask in chat. People are answering and giving good insights in chat. So if you're reading chat, just try to piece it together while we're working through it here. Right now, EL is going to be equal to 1 because we're starting at the beginning again with this change. We'll have 2 infinities, and then we're going to iterate through and say, is EL less than first smallest? In this case, it is, right? Because 1 is smaller than infinity. Now, look at the logic if we do second smallest is equal to first smallest. What will second smallest be equal to in this case? Type it in chat if you understand. This is just asking you what is the code going to do step by step. This is like an understand apply question. right? Because we're just asking you what would Java do if we switch these two statements. So in this case, yes, second smallest will stay infinity because it's equal to whatever first smallest is right now. And since first smallest is infinity, therefore second smallest stays infinity. Then we're going to do first smallest is equal to 1. Right? So this is very different from the first iteration the last time we did this, because before it was 1 and 1, now it's 1 and infinity. Now we go ahead and set EL to 2. And then we're going to say, okay, when we're iterating through, first smallest is equal to 1 right now. We say, is 2 less than first smallest? Yes or no, chat? Okay, great. Yeah, this is like very fundamental, right? I'm not asking any terrible things, hard questions right now. But it is 2 is smaller than second smallest, the second condition here, right? The first condition failed, so we go to the second if else if here, the if statement here. And since it is 2 is smaller than infinity, then we're going to replace the current second smallest with the new EL, which is 2. Right? And then we'll keep going. We're going to set EL to 3. 3 is not smaller than first smallest, and it's not smaller than second smallest, so we leave it alone. And then lastly, at the end here, all we have to do is instead of returning EL, which would be 3 in this case, we're going to return second smallest, because by definition, that's what we're looking for. Right? So we'll return 2, and we know that in our small example, this would work, right? And if we were to test this a little bit more thoroughly, if we had more time, we would see that this works out really well. Right? So all the issues, we made negative infinities become positive infinities. We switched these two statements, and we returned second smallest at the end. I know 1.5 isn't an integer, but can you show what would happen if 1.5 was index 3? Well, if it was 1.5, then 1.5 would replace second smallest, because 1.5 would be less than second smallest, but it would be greater than 1. Right? So, you know, if I think what you're asking here is, let me see if I can draw up a quick example here. So if we were looking at maybe 1, 3, 2 instead, something like this, we would still output 2. And when we are looking at EL is equal to 3, then the first smallest will be 1 and the second smallest will be 3, right? If we were in the middle of this here. I changed the example, so don't get confused. For those of you who are wondering what's going on, I'm answering a question in chat. We went through the first iteration, first smallest was 1, and then we had infinity. Then in the second iteration, we changed, we left 1 alone for first smallest, but then we changed second smallest from infinity to 3. And then once we look at the third iteration, if EL is equal to 2, for example, then we notice that 2 is not smaller than first smallest, it's not smaller than 1, but it is smaller than second smallest, so we'll replace this 3 from before with 2, and that's why we would still get 2 out. Dominic, does that feel good to you? Let me know in chat. All right, cool. Great question. Let's move on. I'm just going to show you the clean copy of all the changes we need to make. Here's all the things we identified was wrong, and here are the corresponding answers. Right? The slides will be up on by the end of today, so you can go back and look at this later. Let's actually take a break now. We'll come back at 3:58.
Professor, I sent you the email about
yeah,
the
thank you.
makeup
I saw
quiz.
it.
Yeah.
I'll
Okay,
answer it.
right.
I'll answer it after class. Okay.
Okay, thank you.
Everyone know that we don't have class on Monday, right? Like there's I think MLK is the holiday. Very relevant right now to celebrate that man, given everything that's going on right now. All right. So again, we're just taking a quick break. We'll come back in about 4 minutes now, and then we'll start again, looking at more pseudocode information. If you have any questions right now, now's the time to ask. I will also point out some things. Usually during this time, I'll point out some announcements that I think are relevant. And in case you're like just waiting, we can talk during this time. So announcements right now. we have a homework party on Sunday at 3 o'clock Eastern time. So we have a homework that's due next Tuesday by 11:59. If you haven't started already, you can learn how to work on it by clicking on this link here on Piazza, where I create a video explaining how you're supposed to work on the homework. This video has kind of small text, so you're gonna have to make the screen bigger. I apologize for that. Next time we'll be better about that. But for the most part, it should cover everything you need to know in order to successfully do the homework. And we'll expect you, everyone, to have watched it before starting, all right? We need, where's the video? It's on this post. I just linked the Piazza post. You click on the Piazza post and then the YouTube video is literally right here. All right. Cool. Do you need to come to the homework
I have a
party?
question.
Yeah, what's up?
So when I try to get into the RAPL 8 for the homework, so if I go in, I'm keep getting a sign that this repository could not be accessed.
If you're having trouble,
if I click work on.
Yeah, if you have having trouble, please click like new post here and ask, like post a screenshot of what you're seeing, and like one of our TAs will be really fast and help you out. This is one of those things where like I don't know exactly what's going on unless I look at it in detail, and Piazza posts are great for that. Homework party, like people are saying in chat, are totally optional, but in case you're finding the homework to be really challenging, if you've looked at it already, you should start looking at it soon. It's pretty involved, but remember, homeworks are meant to test like apply, analyze, evaluate, create, which are all the more hard ones. And this one is almost straight create. But because of that, though, I'm going to hold some basically extra review and walk you through how to solve some of the harder questions. So in this case, question 4. And if you have any questions about the homework in general, whether it's like, oh, I can't get on Replit, or, oh, I'm like stuck, I've written some code, but I don't know what to do next and why my code is breaking, or, oh, I don't know how to start. Those are all like very valid questions, and I will help you with all of them during this time here. So RSVP so that I know how many people are coming and how to set things up. We have a couple of TAs showing up too so that they can answer. Someone is asking, can we use any type of pseudocode we want? For homeworks and exams, I do expect you to use the pseudocode that we are defining in class. So on the course website, there's actually a link on the left here that describes our pseudocode and provides maybe some examples. And it gives you some general rules on how to write it. And we also have some algorithms that you can see here, which give you some examples of pseudocode and how to write it, which should help a lot, especially toward the beginning. This is like not every algorithm in this class. That's a lie. I wrote maybe the first 2 weeks of algorithms, and then I'll write more afterwards. And the expectation is that you can use this as a reference to make sure you feel comfortable understanding how pseudocode should work. I wrote for a lot of these, like the pseudocode and then the actual Java code afterwards, all right? Will homework parties always be on Saturdays? I think I'm gonna try to keep them on Sundays. Sorry, someone asked, will homework parties always be on Sundays? And I'm gonna, for the most part, try to keep it there. You learn about homework, you learn about the homework party. There's a programming club meeting this Friday at 2 p.m. You can go to the link here. This is a optional club. You don't have to come to it, but we teach you how to work on programming. We teach you about topics that would be useful in interviews. And if you want a community to hang out with, especially during COVID times, this club is really cool. We started it last semester. It's student driven. A lot of cool people are in it. A lot of your TAs are in it actually. And the whole point is for you to kind of like learn how to program better, because your classes won't be able to teach you everything. So being able to join a club and practice more is really effective. Are the homeworks going to be like the current homeworks? Yeah, a lot of setup is going to be similar to what we have here. So you definitely need to understand how to use GitHub and Replit if you need to use that. Right, watch the video. If you have any questions, ask on this post. Watch the video. If you have any questions, ask here. You see that we are answering very, very quickly, and we want to help you do your best. All right, so we're gonna get started again. Let's go ahead and start talking about writing pseudocode. Everyone take a deep breath with me. All right, I'll answer some of the, actually, let me answer some chat questions before moving on. I forgot if you mentioned this, do we need to use our school email to set up GitHub? No, you can use your own personal email. As long as in homework 0, you fill out this form here, this survey, getting to know you, it asks for your GitHub, your Gmail, your GSU address and your GitHub username, right? So this is like on purpose so that we can connect your name with your actual work that you're doing, whatever username you're using. All the homeworks. Sorry, if we want to ask you about being a Facebook engineer, is Piazza good for that? Yes, you can. You totally can. Some people have shot me emails too. If you want to do that, that's fine. But Piazza is really great since everyone can see my answer, which can be really helpful. Are all the homeworks going to be like this? For the most part, yes. If you take a test and we can't code it, would you accept pseudocode? Yes. For the certain questions on the homework, you can, for certain questions on the exam, not on the homework. Homework, you actually have to write code. On the test, exam 1, exam 2, and exam 3, there will be certain questions that you can write pseudocode for instead of actual Java code, and sometimes it's actually recommended. You have to write it as well as I'm like describing here and follow all the rules. If you write something that is like badly formed or I can't translate it into code directly, then obviously you're not going to get full credit. But for some of the harder questions on the exam, you can definitely use pseudocode. All right. Let's talk about how to write pseudocode. Give me a yellow in chat if you can see this yellow screen and you can hear me okay. Right. You know that yellow slides are important too for whatever reason. Okay, so basically the rules are this. When the code is clear, keep it the way it is. For example, if we say max so far is equal to max of max so far in EL, this is like fine, right? And later on, you'll see some recursive functions. And this is basically what you would type in for Java or Python or C++, return n times factorial of n minus 1. That's also very chill, very normal as well, right? So if the code pretty much looks like what it would look like in pseudocode, then leave it alone, right? Maybe in Java, you have to say math.max and then add a semicolon, but you can see this is pretty much the same as what you would say in Java. But if something is a little bit weird looking or harder to explain what it does, then you want to use normal words. So an example is max so far is equal to negative infinity is a lot more readable than int max so far is equal to integer.min value. And another example is that for loop we saw earlier. We know we want to look through every single element. That's pretty much what we're doing. So we can say for each element E in L, instead of, int I is equal to 0, I is less than list that size, I plus plus. And another example, just to round us out, if X is odd is a lot more readable and, a lot more understandable instead compared to if X mod 2 is equal 1, which is actually how you would check for whether or not a number is odd in Java. All right. So here are just some small examples. If you need to know more examples, just go and click on the pseudocode reference. Again, this website, csc4520.org, is like your best friend for this class. Everything will be here. You can get to every other thing you need from this class website. And that includes pseudocode rules and examples, as well as algorithms that give you kind of the before and after of pseudocode versus actual code. Moving on, how do I know if I'm writing pseudocode correctly? This actually goes back to the two things I said in the blue slide, which is pseudocode should allow you to only focus on the logic. So anything that detracts from the logic, you probably shouldn't include. And pseudocode should include enough information to write actual code, right? So there shouldn't be too much deviation between what you are writing in pseudocode versus what you would write in Java. And for the most part, you'll see that that is the case. There are sometimes some deviations just so things are more readable, or you can skip some steps sometimes in certain circumstances. But for the most part, you should be able to write real Java code from pseudocode. And this is the only way to do this and get better at this is to practice a bunch, right? I can't just tell you exactly what to do each time. It's not super easy. It's a skill you have to build, just like when you learned programming or learned English for the very first time. It took a lot of practice. You made a lot of mistakes, and over time you got better at it. All right, so we're gonna go ahead and put that practice mantra into play right now. Here's some pseudocode. I'm asking you to write the Java equivalent. And what I actually want you to do is go to Replit. We're gonna go on replit.com or repl.it. 1 second, let me see if I can pull up this without, I named this one. Yeah, I already made a template for this. I'm gonna make this bigger. You can write Java here and run it. I've copied the pseudocode from the slides here. And what I want you to do is take the next 2 minutes or so and try to translate this into working Java. Now, I'm going to go ahead and say that this is really hard and most of you aren't going to be able to write it 100% in 2 minutes. That's not enough time. We're actually pretty short on time for this lecture because of the quiz, but I want you to try and start. And even if you just write one line, or even if you're just actively thinking about it, that's great. And that's what I want you to do. This is closer to, creation. This is the highest level of Bloom's taxonomy here, right? Being able to translate from one language to another is almost like an act of creation. You can also think of it as an act of analysis and evaluation as well, because creation depends on those skills, right? One thing to note for Bloom's taxonomy is that higher level skills always depend on lower level skills, right? So in order to write write Java from the pseudocode, you're going to have to understand this code well enough to translate it, which means that you're also using analysis and also evaluation to be able to create, right? And that might throw you off for some of the questions I asked you on the quiz, because, like I said, there's a dependency. So you might say something is a lower level skill when in fact it's a higher level skill. Or were we supposed to fork? Yeah, you can just go ahead and click fork here. I think there's a easier button for you to click here, but as soon as you start typing, you should be able to have your own copy. Yeah, just go ahead and fork. You should be able to fork automatically. I think this is public, so you should be good. Right, I'll give you another minute. And again, you're just trying to translate this into the Java equivalent. I'm going to cheat and just show you the Java code that I wrote previously. I'm not going to try to do it live because we're short on time. In the future, I will definitely do a lot of live coding. Don't you worry. But for now, we're going to go and give you like that extra minute, and then we'll go through it together. I'll give you a few more seconds, or like another like 20 seconds or so. In the meanwhile, I want to make sure everyone knows that if you're having trouble showing up for lecture, maybe you're in a different country right now and the time zones are really difficult for you, there is a excused absence form for not making it to lecture. Right now it's under quiz 0 logistics and expectations. You just click this form here. This is for people watching the video as well. But there's an excused absences form. You can fill it out, and then we'll talk about how you can make up the work for participation credit, grade, quiz grades, and stuff like that. And this is for anyone who, like, for example, has to work during their normal lecture time, is in a different country. Maybe once in a while, maybe your car broke down, you have to drive someone to the airport, something like that. That's all there. Like it's there for you so that you don't lose points just because you can't make it to lecture. All right, go ahead and copy and paste what you wrote and type it into chat. Even if it's not fully complete, that's totally okay. I just want to see what you have. I know that a lot of you will have made good progress, and some of you got through the first 2 lines, and that's okay, right? You don't have to be a master at programming right now. I just want to see where you're at and understand where the entire class is at. And then we'll kind of tackle it together as time goes on, right? You'll get better over time. Okay, I'm getting some really good answers here. Some of you made it through the entire thing. Some of you started with the header. Some of you had trouble, and that's okay, right? Let's look at it from my point of view. You see here, the first thing we need to do is define the header of the method. So this is talking about Java in this case. We want to essentially take this part here and translate it to its corresponding Java equivalent, right? In this case, we're saying, okay, name of the function, find second smallest. Easy here, right? I'm going to say second smallest just so that it fits on my screen better. But you could said find second smallest and it would have been fine as well. List of integers, LST. Well, you can see the equivalent is here. And we're going to go and check how size is greater than 1 in a second, but just keep that in mind. And then we're going to return the second smallest element in LST, right? This thing output here. that is going to be represented by int, which isn't very informative, but you do need to include that here. Now, if we're moving on, we know that we have to make sure that the list is actually greater than 1. And there's a neat trick in Java called an assert statement that lets you do that. It gives you a chance to write a conditional, and the error that shows up when it's not working. Now, I'm not going to explain this in detail. What I need you to do is to type in assert Java into Google. And then if you look at the first or the second link in Google, you'll get a really good answer for how asserts work, right? I do need you to do, like, if you're stuck on Java stuff, I do need you to proactively learn on your own. Don't expect the TAs to be able to explain every single thing. We'll do our best to point you in the right direction if you're stuck, 100%. Like, don't take this as a sign that we won't help. We will always help no matter what. But I want to make sure that you are not helpless, right? So there's a difference between getting help and being helpless. Don't expect the TAs to always answer your questions, because there are times where you can answer your own question, and we do expect you to try to answer your own question before you ask us. For something like figuring out how asserts work in Java, this is really, really easy, because all you have to do is Google it, and then you click on Geeks for Geeks, because Geeks for Geeks is a great website, and you can totally use it as long as you reference it in your homeworks under citations.txt. And then you can learn about whatever you need to learn, right? So the most important thing is that there's a difference between asking for help and being completely helpless. If you're not trying to figure out what's going on, then you're not doing yourself a service. You're not kind of fulfilling your potential as a student here, right? But we will always help you no matter what. Even if we feel like you could be learning more on your own, we will answer questions. Don't feel intimidated. Always ask if you're unsure, right? And we'll guide you toward getting better at figuring things out for yourself as time goes on. All right, moving on a little bit faster now. We set up first smallest and second smallest. This is not too scary here. We just need to show you, let's see, in a different color here. The initialization here shouldn't be too scary, right? And then moving on, we have the for loop. And the cool thing about the for loop is that in order to get this EL variable, I actually have to have another thing here, right? Now the EL here is automatically given to us, but the EL on the right-hand side is defined explicitly. And then the rest of this logic is pretty much one-to-one, right? And then there's a lot more closed braces that we have to worry about. But let me just point out that this EL here, if I can, 1 second, where's my mouse? Here we go. This EL right here is the same as this EL here, and then we had to explicitly define it in the code, right? So this entire for loop, the equivalencies are here, and then the rest of this logic is pretty much one-to-one, right? There's some braces, there's some punctuation. I'm not going to worry too much about it. And we'll you can pause the video, you can look at the lecture slides, you can stare at the equivalencies on your own in a bit, right? Now, does anyone have any questions or concerns before I move on? Is indentation important when writing your code? Yes, yes, so much yes. Please make your code readable, whether it's pseudocode or Java. I do care about indentation. I want your code to be readable. I will start enforcing that maybe later in the semester, or I'll just point it out when it's a little bit hard to read in your examples or in your homework submissions. Someone's asking, could we have used the for each function? Yes, you could have. I didn't do it here, but you totally can. If you know Java that well and you know how for each works, you can also just Google for each Java, and I'll do that right here. I like for each Java, and then again, Geeks for Geeks is going to tell you how for each loop works, and it gives you an example, right? Instead of saying this, you could say this instead, which is a little bit cleaner, and it works for lists objects as well. So that's something to keep in mind. Is creating the EL variable needed? You don't have to, but it's just nicer to read. Thank you for all your questions. I'm going to move on because I want to make sure we get through everything. So in this case, we have Java for pseudocode. We're going to skip this for now because I want to make sure we get through everything. But this is something I would have you practice on your own later on. And the most important thing about this, the most absolutely important thing to know about this, if you haven't looked at homework 0 yet, there are 2 questions on that homework that are very similar to examples we're seeing on the slides here, right? We went over this idea of max of list, and the first code writing question on the homework is very similar. Instead of max of list of a list, we're doing max of list of an array. And likewise here, adding two lists together, this is like the fundamental like basics of adding two lists together. And that's the same as the add question, number 4. So this is already a huge hint, and I did that on purpose. We're gonna take a very quick break. Instead of 5 minutes, let's take a 3-minute break because I wanna make sure we get through recursion a little bit more. So instead of 5 minutes, 3 minutes here. This is my cat, by the way, in case anyone is interested. But let's take a 3-minute break. We'll come back and then we'll spend the rest of the time kind of working through recursion. Yeah, the clipped ear is to show that he's neutered. This is like very standard for shelter cats, I think. He's taking a nap right now. Otherwise, I would bother him and show him on screen, but he's taking a nap. And he's also been kind of annoying recently, so I kind of don't want him to feel any more stressed. But if you have any other questions, now's a great time to ask. We'll come back in about 2 minutes now at 1:18. We're going to need to go through recursion, and that's really important. Yeah, his name is Nico. Maybe I'll... Nah, I'm not going to make it as a test question. That's silly. Nico. He's a cat. All right, any other questions right now? If you have anything that is a longer question, feel free to either send me an email or make a Piazza post, maybe make it private if you need to, and I'll answer there. We're pretty good about answering Piazza posts. I think our average right now is like 2 minutes, 6 minutes, dang, it went down. We haven't answered these, but I'm in the middle of lecture, so hopefully a TA will answer them. But like between Kaushik, Jenny, and I, we've been answering basically every single post, and we'll continue doing that for the rest of the semester. The idea is that you should feel well supported in this class, and you shouldn't feel intimidated. Like you can ask questions no matter what. If it's a basic question, like an understand or a remember question, that's cool too. Oh, we got a picture of someone else's cat. No, it's a dog. The link is to a dog. Dogs are cool. This is not Nico now, so I should clear that out. Yeah, what a weird cat. Gus looks adorable. Good boy. What a good boy. All right, we got another 30 seconds and then we'll come back. Start coming back if you're like away and staring at your phone or something. I'm really hoping that for those of you who are on the computer and aren't using your phone to like actually attend lecture, that you are able to use these breaks as an outlet for you to get distracted. Right? Like the whole point of these breaks is so that if you are like needing the break, you can use the break to check your phone and stuff like that and not like worry about checking your phone in the middle of me talking. So I'm hoping that everyone can use these break times if you're here in live lecture to really have a chance to recharge. All right. All right, let's move on. Give me a blue in chat if you're with me. All right, I'm hoping this is 50. I should be able to count faster in the future, but the goal is that we're all back from break now. Let's get started. Okay, for recursion. So we only have about 12 minutes left. I believe we end at 4:30, so we don't have too much time. We're only gonna go through the basics today. And for the future, there's gonna be a lecture that I will post on the course website, which will be like right here once it's out, which talks about recursion in more detail. This is a prerequisite to the class. Nico, don't eat my pizza. My cat is trying to get on my desk and eat my pizza. No. But we're gonna have recursion show up as a option, not an optional lecture, a required lecture for homework 1. And I expect everyone to be able to watch it and follow along. All right, but I'm gonna talk about the basics today. So recursion is a way of solving problems using programming, and it's a method specifically by taking an algorithm and using the algorithm within itself. All right, and the key is that it's invoking itself on a smaller instance of a problem. If you don't know what that means, if you've never seen recursion before, I'm speaking a different language to you right now, and that's okay. I will show you an example. Hopefully it will be more clear, and if we have time right now, today, we'll look at an actual coding example. But a function is recursive. So a method, for example, is recursive if the body of the function calls itself either directly or indirectly. Now, recursion is often used to solve problems that can be broken down into smaller subproblems of the same type and can be easier to reason with than other programming techniques. This is a blue slide. Just memorize it for now. You'll remember it, and then understanding and applying will come later, right? I expect that we will work on recursion a bunch throughout the semester. So even if you don't understand everything 100% right now, you will soon. So don't worry. So let's look at the intuitive example. Let's say you're in an ice cream shop and the first 100 people in line get free ice cream. So there's a line outside of the ice cream store. They're about to have their grand opening. So the first 100 people get just free ice cream. You're really into ice cream. Just imagine you are. And so you want to be within the first 100 people. You're already in line. You can't see in front of you, right? Imagine you can't jump high enough. You're kind of short, so you can't jump high enough and see how many people are in front of you. And you can't step out of the line, otherwise you'd lose your spot. But you want to know what place in line you are. So I'll give you 20 seconds. What do you do in this situation, right? This is a real life example of recursion. And for most of you, it should be relatively intuitive. Who has seen this before? Type in "I've seen this" if you've seen this example when used to explain recursion. I'm just curious if anyone's seen this example in the past. Okay, we got a few yeses, a few nos. Okay, we're getting a lot more no's. That's fine. That's great. That means I'm teaching you something new right now, and that's awesome. All right, so go ahead and type in what are you going to do in this case. Call a friend to come count the people in line. Well, what if they want ice cream too? That's a great. I feel like I don't know if you're giving me these answers because that's what you think, or if you're trying to troll me. Either way, I love these answers. If you can call a friend, of course, that would work really well. But let's say you don't have any friends who are available right this second. Ask the person in front of you. Ask the person in front of you. Ask the taller person how many people there are. Ask the person in front. Ask your friend. Wait for the person in front of you to get ice cream. Yeah, that could work, but then you might be waiting in line for a long time and it might not be worth it if you're number 101. All right. So most of you are saying some version of ask the person in front of you, hey, what place in line are you? They're going to have the same problem because they can't step out of line and they want to know. So they're going to ask the person in front of them, who's going to ask the person in front of them. And that's going to keep going over and over and over and over and over until you are at the first person. The first person doesn't have to ask the person in front of them. They just have to say, I'm first. And they tell the person behind them. And then the person who's second in line tells the person behind them, I'm second. And then you have the person in third in line, and then it just passes on and on and on, right? The answer bubbles back, and you're effectively just adding 1 to the number from the person in front of you, right? Stepping out of line means you lose your spot. So if there's, just imagine there's like 100 people behind you. So if you step out of line, you automatically lose your chance at free ice cream, right? So don't do that in this case. All right, so we're going to look at another example in a second, but for now, let's just go and stare at this idea of analyzing recursion, another yellow slide. So there are 3 parts to a recursive function. There are 1 or more base cases, and what that means is 1 or more cases where you're handling the most simple situation, right? That's what a base case is. And you should write this down because this is going to be important and we'll talk more about it later. We're going to have 1 or more recursive calls, which is going to be a situation where the function calls itself, right? So we made the problem smaller somehow. And we're invoking the same algorithm. That's what number 2 means. And then lastly, this one's a little bit more self-explanatory. 1 or more ways to create a solution with the results of a recursive call. All right, so these are really important things to identify in each recursive algorithm. So write these down or kind of make a mental note, especially the blue text here. This is really important. If you've never seen this before, this is something you'll need to know. This is definitely something I'm asking you on a quiz. So if nothing else, just like take a screenshot and remember it for later, or review it in the videos later on. All right, so we're gonna go ahead and look at this for standing in line. You're in line for ice cream. First 100 people get free ice cream. You can't see the person in front of you. How do we identify all of the different parts of recursion? This is analyze, right? In Bloom's taxonomy, this is analyze. This is a level of learning that's pretty high up there. For this situation, what are the easiest cases to handle, right? The simplest cases where you're handling this in your algorithm. And also, once we know the problem exists, we're making the problem smaller somehow, and we're invoking the same algorithm. That's step 2 here. Let me see if I can edit this text so that it fits perfectly. All right, so you should be taking 20 seconds to try to identify all of the parts here. And then once we are good, we're gonna look at the parts together and identify it for this instance. So what is the base case? What are the recursive calls? And what are the ways to create a solution given the solution to a smaller problem? Right, so we're just doing this on the intuitive example, which is why I'm not doing too much explaining, but it should be something that everyone has a sense of, right? Somehow we're invoking the same procedure or invoking the same algorithm, invoking the same technique such that we'll get an answer from that smaller problem. We'll get the answer to the smaller problem, right? Which is what it means to get the results of the recursive call. And then we'll create a solution from that. All right, go ahead and hit enter. What do you have? What is the base case? You are first in line, right? The recursive call is asking the person in front of you, and then creating the solution is just adding 1. Excellent. That's exactly right. So number 1 is one or more base cases. So this blue text here is, if you're the first person in line, then you just say, I'm first, right? Number 2, the recursive call is making the problem smaller. Before it was you and everyone else. Now it's just everyone else, right? So you took the problem of everyone and you in line and made it smaller by removing you from the equation. And then when you make a recursive call, you're just saying, hey, everyone else, what place in line are you? By asking the person in front of you. And then lastly, given the answer, you're going to add 1 to that. And that's what it means to create a solution with the results of a recursive call. Right? So now we're going to look at this for an actual piece of code in the time that we have. Factorial. Factorial is a function that, given a input, we're going to compute the output here. I'm going to actually show you a different version of this in a previous. Here we go. Right. If you don't remember, factorial is represented by this exclamation point, and it means that you're going to take the number and multiply it from 1 all the way up to that number. So if we have 5 factorial, it's 1 times 2 times 3 times 4 times 5. If we have 10 factorial, we have 1 plus 2, 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10, which gives us 3,628,800. I think I said that right. And the question is, like, normally we would code factorial with some sort of like for loop or a while loop, something like that, right? We're going to look at the recursive version in this case and figure out how this works, right? If we, for example, did factorial of 5 here, if we were to call, in this case, I'm going to do it real quick, factorial of 5, right? The first thing we would do is check to see if 5 is greater than or equal to 0, in which case it is, right? 5 is greater than 0, so we pass this assert, we move on. If it wasn't, then in some versions of assert, it'll actually just crash the program, and that's on purpose. But right now, 5 is good. We're good here. Is 5 less than or equal to 0? It's not, so we skip this if statement. And instead, we do 5 times factorial of 4, right? Give me a 5 in chat if you understand this code so far, right? If you've never seen recursion before, this is probably confusing. You might probably saw factorial a million times in the past, and so if it's confusing before, it's probably still confusing now. But I'm going to try to break it down step by step, and then the video I'll post will be much better. I'm going to ask you for about 2 minutes starting from now. I'm going to go through this real quick. Factorial 5 is going to be equal to something, but in order to figure that out, we have to figure out factorial 4, right? When we call a function within itself, it's totally okay. Java will let you do this. And the next thing that'll happen is we're going to call factorial on 4. If n is equal to 4, it's greater than 0. N is not less than or equal to 0, so we skip this. And so we're going to return 4 times factorial of 3, right? You can kind of see the pattern forming here. Every time we go in, we're going to check to see if the number we're at currently is less than or equal to 0. Since it's not, we're going to go ahead and say 3 times factorial of 2, 2 times factorial of 1. And this is what Java will actually do. It'll try to answer this question for you, but every time it has to answer this question, it's going to go and make the problem smaller, right? We're making the problem smaller, and then we're making a recursive call. We're using factorial again within itself to try to compute things. Now, factorial of 0, we know based on this code here, will trigger the if statement. It's going to return 1, right? Since it'll return 1, we can do 1 times 1 here, which will ultimately give us 1 as well. So factorial of 1 here will actually give us 1, and we'll do 2 times 1 here, right? Because 2 times whatever the answer to factorial of 1 is the same as 2 times 1, which gives us 2, right? Which means that this will be 3 times 2, right? Because factorial of 2 is the result of this line here, which we already established was 2 times 1, which is where this 2 comes from. And then we do 3 times that, which gives us 6, which gets passed up to here, right? So Java, in some sense, will just continue to try to find the answer at each level. If you've ever seen Inception, that's probably the best analogy of different levels trying to solve for the same problem over and over again. But if you haven't seen Inception, don't worry. The video I'm going to post will make this a lot more sense. I'll go over this in a lot more detail. But in this case, 4 times 6 gives us 24. So we have 5 times 24 here, which ultimately means that we have 120 here. Right? I went through this very, very fast. We didn't go through this in a lot of detail, and we didn't really break this down into factorial into all of its component parts. But you now have some intuition about the basics of recursion, and we're going to skip right to the takeaways because I respect your time, and I said I'd only take 1 additional minute. And let's look through the takeaways here. First thing you learned today was pseudocode. It's another way of expressing algorithms. It's used to talk about logic without worrying about syntax and compiling. And you can translate from pseudocode to Java and Java to pseudocode. The next thing that's really important to know is that there are techniques called recursion. There's a technique called recursion that allows you to use a function within itself in a method body. We saw a very intuitive version in the sense of waiting in line for ice cream. And there are 3 parts to that idea, right? 1 or more base cases, how to handle the very simple cases in our code or in the problem we're trying to solve. 1 or more recursive calls, so how do we make the problem smaller and then invoke the same procedure to solve the smaller problem? And then 1 or more ways to create a solution with the results of the recursive call, right? I know this might have been rushed, especially for those of you who still feel very uncomfortable with recursion. Recursion is a hard concept. We're doing this first because I need you to know this for the rest of the semester. There's going to be a video that I expect everyone to watch. It will be part of the quiz, so please look out for that soon. I will make an announcement on Piazza when it's out. Other things you should know, there's a homework party that's coming up on Sunday. The homework is already released and due on Tuesday. Check Piazza for details on all of that. Hey, the posts that were posted before are answered. Thank you, TAs. All right, that's all I had for today. Thank you so much for your time. Sorry for going over. If you have any questions or concerns, feel free to let me know. And don't forget to like, subscribe, and comment if you're on YouTube. I'm just kidding. I'm just kidding. Have a good weekend, everyone. Have a good three day break, and let's respect MLK. How should we prepare for the next class? Just work on, I would focus on the homework at this point. Make sure that you're paying attention to the homework, and also watch that video on recursion once it comes out. And I'll post on Piazza when it comes out. I'll also talk about it on Tuesday when that happens, all right? You don't have to worry about much else. Just focus on the homework for now. Is there a quiz Tuesday? No, there's a quiz every second lecture of the week. So it'll be on Thursday again. It'll be every Thursday minus exam times. So if there's an exam that week, obviously you won't have a quiz. It's a good question. All right, any last questions? All right, thanks everyone. I will catch you all later. If you have any other questions, just hop on Piazza or send me an email. But have a good weekend.